What if I told you that somewhere in our universe, there's a star made entirely of diamonds? Or that there are objects so dense that a teaspoon of their material would weigh as much as Mount Everest? Welcome to the Cosmic Freak Show, where reality is stranger than any science fiction you've ever imagined. I'm your host, and today we're going on a journey through space to discover the most bizarre, mind-bending, and downright impossible objects that actually exist in our universe. From stars that shouldn't be possible to planets raining glass sideways, buckle up, because we're about to explore phenomena that will make you question everything you thought you knew about reality. Let's dive into the strangest objects in our universe. Neutron stars, the universe's densest objects. Imagine crushing our entire sun down to the size of Manhattan. That's essentially what a neutron star is. And it's just the beginning of how weird these objects get. Neutron stars form when massive stars explode in supernovas. The core collapse is so violent that protons and electrons are literally crushed together to form neutrons. The result? An object so dense that a sugar cube-sized piece would weigh 6 billion tons. That's heavier than all of humanity combined. But here's where it gets truly bizarre. Neutron stars spin. And when I say spin, I mean they rotate up to 700 times per second. That's faster than a kitchen blender. Some neutron stars, called pulsars, emit beams of radiation from their magnetic poles. As they spin, these beams sweep across space like cosmic lighthouses, and we can detect these pulses here on Earth. The magnetic field of a neutron star is 1 trillion times stronger than Earth's. If you had a neutron star the size of a city anywhere in our solar system, it would strip the magnetic data from every credit card on Earth, get within 600 miles of one, and the magnetic field would literally rearrange the atoms in your body. The surface of a neutron star is equally mind-boggling. It's essentially one giant atomic nucleus, the largest atom in the universe. Mountains on neutron stars are only millimeters tall because gravity is so intense. And if you somehow managed to drop something from just 1 meter above the surface, it would hit the ground at 7 million kilometers per hour. But perhaps the strangest thing about neutron stars, they ring like bells when disturbed, creating starquakes that release more energy in milliseconds than our sun produces in 20 years. Black holes, where physics breaks down. Black holes are the universe's ultimate mystery. Regions of spacetime where gravity is so strong that nothing, not even light, can escape. But the reality of black holes is far stranger than most people realize. First, let's talk about time dilation. As you approach a black hole, time literally slows down relative to the outside universe. If you were watching a friend fall into a black hole, you'd see them slow down, redshift, and eventually appear to freeze at the event horizon, even though from their perspective, they'd fall in normally. But here's what's truly weird. According to our current understanding of physics, if you fell into a black hole, you'd experience something called spaghettification. The gravitational difference between your head and feet would stretch you into a long, thin shape, like a piece of spaghetti. Not exactly a pleasant way to go. At the center of every black hole lies the singularity, a point of infinite density where the laws of physics as we know them completely break down. It's smaller than an atom, but contains the mass of entire stars. What happens at a singularity? We honestly don't know. Our mathematics simply can't describe it. Recent discoveries have revealed that black holes aren't actually black. They emit something called Hawking radiation and slowly evaporate over time. Paradoxically, smaller black holes evaporate faster than larger ones. A black hole with the mass of our sun would take longer than the age of the universe to evaporate. But a black hole, the mass of a mountain, would explode with the energy of 1 million hydrogen bombs. And here's something that will blow your mind. Some scientists theorize that our entire universe might be inside a black hole. The Big Bang might actually be what falling into a black hole looks like from the inside. Magnetars, the universe's most powerful magnets. If neutron stars are weird, Magnetars are their psychotic cousins. These are neutron stars with magnetic fields so powerful they redefine what we thought was possible. A magnetar's magnetic field is 100 million times stronger than any magnetic field we can create on Earth, and a quadrillion times stronger than our planet's magnetic field. To put this in perspective, a magnetar, located halfway between Earth and the Moon, would strip all the magnetic data from every credit card on our planet. But it gets stranger. The magnetic field of a magnetar is so intense that it warps the very atoms around it. Atoms become stretched into thin cigars, completely changing how chemistry works. If you were within 600 miles of a magnetar, the magnetic field would interfere with your nervous system's electrical impulses. You'd literally lose consciousness before the radiation killed you. Magnetars occasionally have what astronomers call starquakes, cracks in their ultra-hard crusts. When this happens, they release more energy in 1/10 of a second than our sun produces in 100 years. In 2004, a magnetar 50 light-years away had such a starquake that it temporarily blinded satellites in our solar system and affected Earth's magnetic field. The most terrifying part? These starquakes can literally tear apart the fabric of space-time itself, creating gravitational waves that ripple across the universe. Magnetars are so extreme that they're essentially testing the limits of what matter and energy can do in our universe. The diamond planet FT5 Cancri E, located 40 light-years from Earth, is a planet that sounds like something from a fairy tale. 55 Cancri E, a world made largely of diamond. This super-Earth is about twice the size of our planet, but 8 times more massive. What makes it truly bizarre is its composition. The planet formed in a carbon-rich environment, and under the extreme pressure and temperature conditions, much of its interior crystallized into diamond. We're not talking about small diamonds here. This planet contains more diamond than exists in Earth's entire crust. If you could somehow mine this planet, you'd crash the diamond market permanently. The planet is worth about $26.9 nonillion. That's 384 quadrillion times more than Earth's entire GDP. But 55 Cancri E isn't just valuable, it's hellish. The planet orbits so close to its star that a year there lasts only 18 Earth hours. The dayside temperature reaches 400 degrees Celsius, hot enough to melt copper. The nightside, meanwhile, is a relatively cool one, 100 degrees. What's particularly strange is that this diamond world has an atmosphere. Despite the extreme conditions, it maintains a thin atmosphere of hydrogen and helium. Scientists think it might even have weather, but instead of water clouds, it would have clouds of vaporized rock. Imagine standing on a world where the ground beneath your feet is literally made of the most precious substance on Earth, while above you, it's raining molten rock under a sky glowing with the heat of a nearby star. Rogue planets, the cosmic wanderers. Not all planets orbit stars. Scattered throughout our galaxy are billions of rogue planets, worlds that have been ejected from their solar systems and now drift alone through the cold darkness of space. These cosmic orphans are more common than we ever imagined. Recent estimates suggest there might be more rogue planets in our galaxy than there are stars. Think about that. For every sun you see in the night sky, there could be multiple planets wandering, unseen in the void between stars. Some of these rogue planets are truly bizarre. Without a sun to warm them, their surfaces are frozen wastelands, with temperatures near absolute zero. But some might have thick atmospheres that trap geothermal heat from their cores, creating pockets of liquid water beneath ice-covered surfaces. One of the strangest rogue planets discovered is called CFBD-SIR 2149-403. This world is roughly the size of Jupiter, but completely alone, floating through space about 100 light-years from Earth. It's been wandering for millions of years, and it glows with a dim infrared light from its own heat. But here's what's truly mind-bending. Some rogue planets might support life. Deep beneath their frozen surfaces, geothermal vents could provide energy for ecosystems completely independent of any star. These would be biospheres that exist in permanent darkness, sustained entirely by their planet's internal heat. There might even be rogue planets with moons. Imagine a world system drifting through space, a planet with its own satellites, creating tides and geological activity, all happening in the eternal night between stars. It's like a pocket of planetary activity completely disconnected from any solar system. Quasars. When black holes go wild. Quasars are what happens when supermassive black holes go absolutely berserk. These are the brightest objects in the universe, shining with the light of trillions of stars, while being smaller than our solar system. At the heart of every quasar is a supermassive black hole that's actively feeding. As matter spirals into the black hole, it forms what's called an accretion disk. The friction and magnetic forces in this disk heat the material to millions of degrees, causing it to shine brighter than entire galaxies. But the truly strange part isn't the light, it's the jets. Quasars shoot out beams of particles at nearly the speed of light, extending for millions of light years. These jets are so powerful, they can affect the formation of stars in galaxies billions of light years away. They're literally reshaping the structure of the universe. The energy output of a quasar is almost incomprehensible. A typical quasar produces 100 times more energy than our entire Milky Way galaxy. If you replaced our sun with a quasar, it would appear as bright as the sun does from Earth, even from a distance of 33 light-years. What's particularly weird is that we mostly see quasars from the early universe. They were much more common billions of years ago, when galaxies were younger and had more gas to feed their central black holes. In a sense, looking at quasars is like looking at the universe's wild adolescence, a time when galaxy formation was chaotic and violent. Some quasars change brightness dramatically over just days or weeks. Since light can only travel so fast, this tells us that the energy-producing region is incredibly compact, smaller than our solar system, but producing more energy than a trillion stars. Dark matter structures, SEN, the invisible universe. Perhaps the strangest objects in our universe are ones we can't even see. Dark matter structures. Dark matter makes up about 85% of all matter in the universe. Yet it doesn't interact with light or ordinary matter in any way we can detect. We know dark matter exists because we can see its gravitational effects. Galaxies rotate too fast to be held together by just the matter we can see. Galaxy clusters move in ways that only make sense if there's much more matter than we observe. The cosmic web, the large-scale structure of the universe, is shaped by dark matter. But what is dark matter? We don't know. It could be particles that barely interact with anything. It could be primordial black holes. It could be something we haven't even theorized yet. What we do know is that dark matter forms its own structures, vast halos around galaxies, filaments stretching across space, and dense clumps that we can map by their gravitational effects. Here's what's truly strange. There might be entire dark matter galaxies out there, structures made entirely of dark matter with no ordinary matter at all. These dark galaxies would be completely invisible, but could be as large as the Milky Way. Some scientists theorize that dark matter might form its own complex structures, dark matter planets, or even dark matter life. If dark matter particles can interact with each other in ways we don't understand, there could be an entire shadow universe of dark matter objects existing alongside our own. Recent simulations suggest that the smallest dark matter structures might be incredibly dense. Dark matter clumps the size of Earth, but with the mass of the Sun scattered throughout our galaxy. If one passed near our solar system, we'd detect it only through tiny changes in planetary orbits. The Boötes void, the great nothing. In the constellation Boötes lies one of the most unsettling objects in our universe. A region of space so empty that it's been nicknamed the Great Nothing. The Boötes void is a roughly spherical region of space, about 330 million light-years in diameter, that contains almost no galaxies. To understand how strange this is, consider that in a typical region of space this size, you'd expect to find about 20 galaxies. The Boötes void contains only about 60. It's like finding a major metropolitan area with only a few dozen houses scattered across it. What makes the void even more mysterious is that we don't know how it formed. Computer simulations of the universe's evolution can't easily explain how such a large empty region could develop. The void is so large that light takes 330 million years to cross it. It's one of the largest known structures in the universe, defined entirely by what's not there. From the perspective of any hypothetical aliens living in one of the few galaxies inside the void, the night sky would be nearly empty. They might not even know that other galaxies exist. Their entire observable universe would contain only a handful of other galaxies, making them cosmically lonely beyond our comprehension. Some scientists have proposed that voids like this one might be where dark energy, the mysterious force accelerating the universe's expansion, is strongest. The void might be expanding faster than the rest of space, stretching what few galaxies exist there further and further apart. Standing at the edge of the Boötes void and looking in would be like staring into the abyss of space itself. A reminder that our universe is not just full of strange objects, but also strange absences. Strange stars and impossible objects. Our universe is full of stars that shouldn't exist according to our understanding of stellar physics. Yet there they are, challenging everything we thought we knew. Take Przybylski's star, located about 370 light-years from Earth. This star contains elements that shouldn't exist in nature, including short-lived radioactive elements like actinium and holmium. These elements decay so quickly that they shouldn't be found in any star. Either this star has some unknown nuclear process creating these elements, or it's somehow incorporating material that was created very recently on a cosmic timescale. Then there's the Methuselah star, officially known as HD 140,283. This star appears to be older than the universe itself, about 14.5 billion years old, while our universe is only 13.8 billion years old. It's like finding a person who claims to be older than human civilization. Scientists are still trying to resolve this paradox. Wolf-Rayet stars are perhaps the most violent stars in the universe. These massive stars have shed their outer hydrogen layers, revealing cores that burn at temperatures of 50 degrees Celsius. They blast stellar wind into space at speeds of up to 30 kilometers per second. Some Wolf-Rayet stars lose the equivalent of Earth's mass every year just from their stellar wind. But perhaps the strangest stellar object is the Thorn Zhitkau object, a theoretical star within a star. These bizarre objects would form when a neutron star gets swallowed by a red giant star. The result would be a star with the neutron star as its core, creating nuclear processes that simply don't exist anywhere else in the universe. In 2014, astronomers think they may have found the first Thorn Zhitkau object, a star called HV 2112, in the Small Magellanic Cloud. If confirmed, it would be one of the most exotic objects ever discovered, a star powered by physics we're only beginning to understand. Time dilation objects and gravitational anomalies. Some of the strangest objects in our universe aren't just weird because of what they're made of, but because of how they affect the very fabric of space-time itself. Frame-dragging effects around rotating massive objects create regions where space and time are literally twisted. Around rotating black holes, there's a region called the ergosphere, where it's impossible to remain stationary relative to distant stars. Space itself is being dragged around by the black hole's rotation. Gravitational time dilation means that time passes differently depending on how strong the gravitational field is around you. On the surface of a white dwarf star, time runs about 50 seconds slower for every minute compared to Earth. On a neutron star, this effect is so extreme that time crawls at just a fraction of the normal rate. But perhaps the strangest temporal object is a closed time-like curve, a theoretical path through spacetime that leads back to its own past. While we haven't found any confirmed closed time-like curves, some solutions to Einstein's equations suggest they might be possible around certain exotic objects. Wormholes, if they exist, would be shortcuts through spacetime connecting distant regions of the universe. Traversable wormholes would require exotic matter with negative energy density, something we've never observed but can't rule out entirely. The strangest part about these objects is that they remind us that space and time aren't the fixed stage we imagine them to be. They're dynamic, flexible, and can be warped, twisted, and stretched by matter and energy in ways that still boggle our minds. Conclusion: the universe's greatest mystery. From diamond planets to time-dilating stars, from invisible dark matter to voids of nothingness, our universe is far stranger than we ever imagined. These objects challenge our understanding of physics, chemistry, and reality itself. But perhaps the strangest thing of all is that we exist to observe them. In a universe filled with neutron stars, black holes, and cosmic voids, somehow matter organized itself in just the right way to create beings capable of wonder, curiosity, and the drive to understand.